Hi, it's Paul from QTech here. I'd like to take you through the feature set you would expect from an advanced multifunction tester, and in our case it's the KT66DL, which also has some special unique features that I will show you. First thing to appreciate with the QTech philosophy is for the best and easiest to use user interface, we have a single rotary dial, 4 soft keys and a dot matrix screen. The dot matrix screen enables you to have multiple pieces of information for each specific test. It saves scrolling and gives you better feedback. The dial itself is arranged such that it's in the order of the tests that you do, starting off with continuity, then insulation, etc. So in continuity, we have the 4 soft keys giving you your null, your buzzer off and off, off and on. Over here, we've got a selection of a 200 milliamp or a 15 milliamp test current. 15 milliamp you may use for testing electrical motors. In the norm, it will be set at 200 milliamp. The PAT function here, the PAT function is designed for electricians, electrical contractors who don't particularly want to do PAT testing, but inevitably get drawn into it to keep specific customers happy. A typical scenario may be a landlord, you do their condition reports, and they've also got some portable appliances that need testing. This function works in conjunction with our PAT adapter. Here you simply plug your appliance in the front and your test leads in the top here, and the connection diagrams are as these illustrations: class 1 insulation, class 2 insulation, and for earth testing for class 1 appliances. I'll just demonstrate that because this also gives you a download which you can use as your certification. So I'm going to put PAT on, and we have 3 levels of limits in line with the latest code of practice. I'm going to set it to 0.1, which is the common one. I'm going to do a test. It's going to fail because there's nothing connected. Then I'm going to press memory. Now memory, we have some flags that we can change. It automatically gives you an appliance ID. You can change it should you want. It enables you to put a site. In the scenario that it's a house in a street, you could put the house number, should that suit you. And also we have a place here for appliance code. So again, if it suited you, you could have all your kettles as 01, all your fans as 02, all your computers as 03. But in the scenario that we've got 6, 10 or 20 appliances we're testing at one site, we're not going to lose them. The appliance ID is going to locate them. So we have the option should you need them. So moving on to insulation. Now here we can see the benefit of the dot matrix screen. It gives you a digital bar graph of how the insulation is testing. Test results comes here, and you also have the opportunity to do dielectric and your polarization index. We have a range from 100, 250, 500 and 1000. For PAT testing, again, you've only got 250 and 500 in line with the standard. On F1, we've also given you the option to do your surge protection device, checking that it's dumps the voltage to earth at the specified level. Here it does a 1000 amp ramp test up to 1000 amp, steadily increasing. When the voltage breaks down, it will display the DC voltage and the AC voltage. The AC voltage is the one, of course, that is the specification of the device you're testing. Next, we have loop impedance, and if any test defines the quality of a multifunction tester, it is the loop impedance function. Here we strip out the high current from the low current, the ATT, anti-trip technology. In high current, first thing to notice is we have the standard 0.01 resolution loop. This is a 6 amp test. It's 6 amps because should you be doing, say, a ZS without a RCD in the circuit, anything higher than 6 amp, you're in danger of pulling out a 6 amp MCB. So generally speaking, high current loop is set at 6 amps. We have on this tester a 0.001 resolution. The exciting thing about this, it's got a 25 amp test current, and that enables us to give a genuine 50 kA range on the prospective short circuit current on PFC ranges. At that level of resolution, we need to tell the instrument which test leads we're using. There's a couple of digits difference in their resistance, and to get that resolution, we need to simply tell the instrument whether it's mains lead or distribution board lead. And just to reiterate, the 0.01 resolution, if you're doing your prospective short circuit current, 0.01, if that's the reading, it will give you a 23 kA value. If it was to be one digit higher, 0.02, that would halve the value, so you get 10 kA. So you really need the 0.001 resolution test to give you accurate PSCs when you are close to the transformer. Over at F4 we have a limit function. Press that and enter. You'll see there is every overcurrent protection device you'll come across in the UK, and you simply select the current rating, the disconnection time, and you have a factor, the 0.8 rule of thumb factor you can put in, or you can leave it at without the factor. In this case, the limit is 5.82. There it is sitting up there. The next function on the dial is an ATT low current. First of all, we have a standard 3-wire test. Low current anti-trip loop tests are generally 3-wire. This is the best option to overcome electronic noise. What we all do, we do a high current, again generally 6 amp live neutral, and then a low current neutral earth test. The low current has to be below 50 milliamp because we're testing through 30 milliamp RCDs, and it has to be even lower than 50 milliamps in case there's some standing leakage, and typically ours is 11 milliamps. So this is a good robust low current circuit, and has every chance of overcoming electronic noise. The other problems we have with loop testing is RCD uplift, a situation where the test current interferes with the sensing of the RCD, and it ends up giving an uplift on the loop. We've exhaustively tested the KT66 and it's very robust with that regard. The third problem is contact resistance, and you'll find it particularly with old switchgear. If you do a loop test and the value is a bit high, you'll obviously do it again just to check, and it's a few digits lower, and then you do it again to check which one's right, and that quite often is a little bit lower again, and you can do it several times, and maybe 5, 6, 7, 8 times. You eventually get a consistency of result. That is the effect of each test slightly overcoming the contact resistance, and that contact resistance starts right from, let's say, using the mains lead, the pins on the plug in the socket, especially if the socket isn't used that much. The way we can overcome contact resistance also with this pulse function. Pulse on will pulse the test current first before it takes the reading, and that gives you every chance to overcome that before you have the effect on your results. Now, during the development of this tester and the advent of charging points, EVSEs, electric vehicle supply equipment, are being used and is being taken up very rapidly now, we noticed that some chargers were very sensitive to the 3-wire test current and would trip. So we have a 3-wire EV test, we call it, and this reduces the current further and elongates the time it takes to do the test, and we end up with the same place in regards to the good secure result. We've also gone one step further and even a lower test current, just in case future charging points are even more sensitive. Now we've added a 2-wire. Previously we have not been happy with this because of its sort of random nature, but just latterly we've managed to improve the algorithms, and it is now fairly robust test even when there's a level of electronic noise in the circuit. And its true value is on lighting circuits, where, for instance, you would normally have to go to the end of a string of lights in the ceiling, find the end, get up into the ceiling, and with a 3-wire test, do a test at height. Now with this you can do that test at the plate switch, remove the plate switch, find your switch live and earth, and do this low current test. And obviously with lighting circuits, they're the lower current, and in this case again it's a type B 6 amp, and the max ZS is 5.82, which gives us a lot of room for the tolerances to play out. I've had one gentleman come onto the stand at Elec show, very pleased with this instrument, and he said that he uses that as his default setting. He's so happy with it. The next function we have is our RCD function. Now the 18th edition caught us all out a little bit with the sudden sort of rejection of type AC RCDs and the default position that we should always be putting type A's, based on good reasoning, I may add. But the type ACs are going to be around for a long time yet, as there's thousands installed. First thing to notice, the range here, we have a variable RCD option, 10 milliamps, 30 milliamps, 100 milliamps, 300, 500, and 1000 for type AC. Also the variable we can set to whatever we want. In the case of a type AC, from 10 milliamps to 1000 milliamps, 1 amp. So running down the list of, I'm just going to set this to 100, running down a list of RCD types it covers. There's type AC, ACS, A, AS, B, BS, type F, and type EV. Now, we're probably all aware that electric vehicle charging points can come with either a type B RCD or a type A with a 6 milliamp RDCDD device. This test to the KT66 enables you to test those individually for timing, for tripping level, or as part of an auto test. What I'm going to do, I'm going to set it in to auto, and I've got one hooked up here, so I'm just going to connect up here. And finally this one. Make sure this is on. In this case I got an RFID unit, so I've got to make sure you hear the contacts come in. The polarity indicators show we got power, and I'm going to simply press the test button and we'll do the 6 milliamp tripping time. We see there it's 368.8. I use the card in this case to reset. It takes a few moments. You hear it clicking. There you go. So I'll do the second test. Now I'll do 2 half times. Whoops. Oh, sorry, I must just reset this. You'll hear it clicking again. Takes a few moments. That's on the first half of the sine wave. That's on the second half. Now we've got the first trip of the RCD. I'm going to abort it there because it is a little bit fiddly to reset the RCD each time. But what I want to demonstrate now is the memory function here. So I'm going to press memory, and it enables us to save that and give it some flags, so which circuit it was on, which board and which site. I'm going to hold down the memory button now, and we've got our history. I'm going to come back to one I've done previously. Here we go, and it's the same EVSE, and we can see the full results there, and also these flags we can give it. So on to the volts function. Here we have on the same screen live earth, live neutral, and neutral earth. Neutral earth particularly interesting. We can foresee that we like to have any problems. Phase rotation, we get phase-to-phase voltage, L1 to L2, L2 to L3, L3 to L1, plus the sequence of the phases. And last but not least, we get an earth electrode, a resistance test. The tester, there's three ways to start a test. One is a single press of the test button. One is a press and lock down, that's continuous testing. And then we have a switch probe, which is a really tidy and neat device, 4mm tip at the top for GS38, and we have a right angle connector now going into the instrument. Our test leads are really popular. We call them the G7 test leads. We put a lot of energy into ensuring the integrity of the strain relief, doing pull-out tests, doing bending tests, and these test leads work in cold and warm conditions and are as robust as they get. We also have obviously the socket breakout function. We can get our test leads into a socket outlet. But what is not so commonly known is that we have a version of that with a flying lead. Now here you can put any connector you like. Typically it could be a little plug for a click type sealing accessory, and it enables you to get into the circuits to test with your 4mm test leads very quickly. We've also got that in a 3-phase version, so whatever industrial socket you want to, industrial plug you want to put on there, you can to suit what you want to test. And last but not least, we have our light mates that enable you to get into a light fitting, be it Edison screw, SES, BCS, and GU10. So that, in a nutshell, is our KT66DL multifunction tester.